Number 54, solve each equation by finding all real roots. So again, we're going to start with possible zeros, and since this number coefficient in the leading coefficient is 1, we will just work with the possible zeros coming from the factors of the last number here, which is 15. So the possible zeros will be plus or minus 1, 3, 5, and 15. So let's start by writing the coefficients down. I'm going to test the first number, which is negative 3. And bring down the 1, going to multiply, we have negative 3, and that's negative 5, that's going to be 15. Combining, we have 1 times negative 3, we have negative 3, and combining it, we have negative 5. Multiplying is a positive 15, and we got a 0. So therefore, we know that negative 3 is a root. So let's rewrite the rest of the terms. We will have x to the third. We're reducing it by 1, so it went from 4 to 3. And then this is x squared plus x minus 5. So we're going to write this as f of x equals x plus 3. That's going to give us the root of negative 3. And then x to the third minus 5x squared plus x minus 5. From here, we can go ahead and use grouping to finish the problem. So we're going to group the first two and group the last two and factor out the common terms. So in between these first two terms, we have x squared. So we're going to factor that out. We have x minus 5 plus, there is no common factor between x and 5, so we're going to just factor out 1, and we have x minus 5. Now since we have the last two terms looking the same, we're going to factor that out. So what goes in the front is x squared plus 1 with x minus 5, and that's how you factor. And then don't forget to bring down the x plus 3. So this is the complete factorization for the problem. And to get the roots, it will be x equals negative 3, the first one that we found. And then the second root that we found is x equals 5 from x minus 5. And from the last one, which is x squared plus 1, we can set that equal to 0 and solve. So minus 1 on both sides. So we have x squared equals negative 1. Taking the square root, we have x equals plus or minus I. So those will be the complete set of solutions right here. End of problem.